In Unit 6, Part 3, we're going to look at another way to solve equations that include fractions. We call this method clearing fractions. We're also going to do the same thing with decimals. We're going to clear out decimals to solve. So if you look at the first part, it says solving an equation by clearing fractions. Again, the first thing we're going to do is box and rewrite. Before we rewrite, though, actually, you're going to want to find the least common denominator. So you want the least common denominator of all three of these fractions. Which, if you need help remembering how to do that, please come get help from me individually. But in this case, the least common denominator would be 12. And when we say clearing the fractions, we're going to multiply every fraction by the least common denominator. So when I rewrite this, I'm going to do 12 over 1, because my least common denominator is 12. I'm going to do that times 112. Then I'm going to do 12 over 1 times 2/3 x. And I'm going to do 1/3 times 12 over 1. So everything's getting multiplied by the least common denominator of 12. Now, the reason why we do this, if you look at this first one, 12 and 12 cancel each other out, so I'm just left with 1. 12 and 3 reduce to 4 and 1. So when I do 4 times 2, I get 8x. Notice that the negative is still there. And then on the right side of the equation, 12 and 3 reduce again. This is 1, this is 4. So I just have 4 over here. So I've made it a lot easier to work with these numbers. Now I just need to get x by itself like always. So I'm going to subtract 1 from both sides. I'll get negative 8x equals 3. And then I need to divide both sides by negative 8. So I'll get x equals negative 3 for my answer. I'll let you guys try that with number 2. If you need help, just ask me. Looking at the next section, it says solve an equation by clearing decimals. So the way that you're going to do this is you're going to look at the equation and see the greatest number of decimal places you have. So for number 1, you only have 1 decimal place for 2.3 and 9.2. For number 2, for 10.56, we have 2 decimal places. However many decimal places you have, that's the power of 10 that you multiply by. So for the first one, we multiply everything by 10. For the second one, we multiply everything by 100. So let me show you what I mean by that. And I'll show you on number 2 since it's the one that's by 100. So I'm going to take every part of this equation and multiply it by 100. And I might run out of room. So everything's being multiplied by 100. Okay? So when I multiply by 100, I just move the decimal to the right 2 places. So 26.4 is going to become 2,640. 6.6x is going to become 660x. And 10.56 is going to become 1,056. But since I'm multiplying by 100, I just go 2 places to the right. So now, again, I only have integers. I only have whole numbers, no decimals. So now I can solve. So I need to subtract 1056 from both sides. So on the left side, when I subtract, I'm going to get 1584. And then on the right side, I'll just have 668 left. Now, since my answer started in decimals, then I'm totally fine having my final answer in decimals as well. So 1584 divided by 660 is going to give me 2.4, which will be equal to x. So if my question, or if my original problem started in a fraction, I ended in a fraction. If it started in decimal, I ended in a decimal. Looking at the bottom of the page, it says solving an inequality by clearing fractions. So this is going to be the same thing that we did in the first part, just with inequalities instead of with equations. So number 1, I'll leave for you guys. I'm going to do number 2 just since it's got a lot of negatives. It's a little bit tricky. Remember, the first thing I want to do is find my least common denominator, which for this isn't that hard. It's just going to be 9. So I'm going to box it. When I rewrite it, I'm going to multiply everything by 9 over 1. Everything's getting multiplied by 9 over 1. So again, when I multiply, it's supposed to make life a lot easier. These 9's cancel out, so I just have negative 5x because it's over 1. The subtraction sign stays there, but the 9's cancel, so I'm just left with 1, and that's less than, and then 3 becomes 1, 9 becomes 3, so it's less than 3. Now I can solve from here, so I need to add 1 to both sides. So I'll get negative 5x is less than 4. Then I'll divide both sides by negative 5. Now remember, when I divide by negative 5, my inequality symbol is going to flip, and I can just leave that negative 4 over 5. Started in fractions and ended in fractions. Alright, number 1, I'll let you guys try. If you look at the next page, it says describe the possible values of x if the area of the rectangle is at least 40 square inches. Okay? At least right here tells me that I'm going to have an inequality. Okay? And at least actually we know it's going to mean greater than or equal to. So we need to use our area formula, which is just length times width. Okay? So my length is 4. My width is 5/8 x plus 5. And then it's at least, so I know it's going to be greater than or equal to 40. Now, I have to use the distributive property here. So I'm going to do 4 over 1 times 5 over 8x plus 4 over 1 times 5 greater than or equal to 4. So 4 becomes 1, 8 becomes 2, so I have 5 over 2x. And then I'm just doing 4 times 5, which is 20, and greater than or equal to 40. So to solve, I'm going to subtract 20 from both sides. So I'll get 5 over 2x is greater than or equal to 20. And then here I'm left with the multiplicative inverse. So I can multiply both sides by 2 over 5. When I do that, all these wipe away. So I have x is greater than or equal to 20 becomes 4, 5 becomes 1, 4 times 2 is 8. So x is greater than or equal to 8. Right, and then the rest is review problems, and that's all we have for part 3.